work? Well, say hello to your new best friend, the drone. Using drones equipped with high-resolution cameras and LiDAR scanners has completely revolutionized surveying and site mapping. What used to take a team of surveyors weeks to accomplish can now often be done by a single drone operator in a matter of hours. This isn't a futuristic gimmick. It's happening right now, and it's a massive leap in efficiency and safety. Drones can generate incredibly detailed three-dimensional topographic maps, conduct volume calculations for earthworks, like how much dirt you need to move, and monitor construction progress with a level of detail you could never get from the ground. The key is not just flying the drone, but knowing how to use the software that processes the data, like Pix4D or Drone Deploy. These platforms stitch together thousands of images to create precise orthomosaic maps and three-dimensional models. For large-scale land development, mining operations, and infrastructure monitoring, drone skills are becoming a must-have. It's a perfect example of how technology is augmenting our abilities, letting us do our jobs better, faster, and safer. We've talked a lot about software and technology, and it's all critically important. But I'm going to tell you a secret. The most successful engineers I know aren't just technical wizards. They are master communicators. You can be the smartest person in the room, but if you can't explain your complex ideas to a client, a city council, or your own team, your brilliance is trapped in your own head. This is where soft skills come in, and frankly, they're not soft at all. They're power skills. We're talking about crystal clear technical communication and report writing. Can you write a report that is both technically sound and easy for a non-engineer to understand? But it goes beyond that. Are you a good collaborator? Engineering is a team sport, and you need to be able to work effectively with architects, contractors, and other specialists. Do you have leadership potential? Can you motivate a team and take ownership of a project? How are your presentation skills? One day you will have to stand in front of a client and convince them that your multi-million-dollar design is the right one. And finally, negotiation. Whether you're negotiating a contract, a change order, or just a deadline with your boss, this skill is priceless. These are the skills that turn a good engineer into a great leader. Now let's shift gears and talk about some skills that are on the decline. And this first one might be a little controversial for some: pure two-dimensional AutoCAD drafting. For decades, AutoCAD was the undisputed king, the essential tool that every single engineer had to master. And look, it's still used. But here's the critical distinction. It's being used less and less as a standalone skill. The industry has moved toward the integrated three-dimensional and BIM environments we talked about earlier. Simply knowing how to draw lines, arcs, and circles in 2 dimensions is no longer enough to make you a competitive candidate. The problem with pure two-dimensional drafts is that they are just lines on a page. They are dumb drawings. They don't contain the rich data of a BIM model, and they are notorious for creating coordination problems. A change made on one drawing has to be manually updated on 10 others, which is a recipe for errors. The risk of clashes between different systems, like plumbing and electrical, is huge. The modern alternative is to use tools like AutoCAD Civil 3D or Revit, where the two-dimensional drawings are generated automatically from the intelligent three-dimensional model. So if you update the model, all the associated drawings update too. The skill isn't dead, but its context has completely changed. Let's take a walk down memory lane. Do you remember learning how to use chains, measuring tapes, and dumpy levels in your university surveying lab? It was a rite of passage for every civil engineering student. We learned the principles of triangulation and leveling through painstaking hands-on effort. And while understanding those principles is still fundamentally important, the actual practice of using these manual tools on a professional job site is becoming increasingly rare. It's like learning how to use an abacus to understand math, a great educational tool, but you wouldn't use it to do your company's taxes. The simple truth is that modern tools have made these manual techniques largely obsolete for professional work. Total stations, GPS and GNSS receivers, and now drone photogrammetry are infinitely faster, more accurate, and require less manpower. Why spend a day with a team of 3 people meticulously measuring a plot of land with a tape and level when one person with a GPS rover can do it in an hour with millimeter accuracy? Now, these manual skills are still taught in academics to instill a foundational understanding, and they might be used on very small-scale, low-budget projects, but relying on them as a primary professional skill is a career dead end. Another classic skill that's being transformed by technology is quantity estimation. This is the process of calculating exactly how much material you'll need for a project, Like, how many cubic meters of concrete, how many tons of steel, or how many linear feet of pipe. In the old days, this meant poring over two-dimensional drawings with a scale ruler and a calculator, manually counting every single item, and painstakingly entering it into a spreadsheet. It was honestly incredibly tedious, time-consuming, and prone to human error. Forgetting to carry a 1 or misreading a dimension could lead to budget overruns worth thousands or even millions of dollars. Today, this manual process is being completely superseded by software. Remember our friend BM? One of the most powerful features of a BM model is that it can generate a precise quantity takeoff automatically with the click of a button. Because every object in the model contains data about what it is, the software can instantly tell you that you have exactly 4,782 cubic feet of concrete and 12.3 tons of rebar. Specialized estimation software can then link this data directly to cost databases to generate accurate budget reports. While the ability to do a quick, back-of-the-envelope calculation is still useful, relying solely on manual estimation from two-dimensional drawings is inefficient and risky in today's data-driven world. The role of the site supervisor or field engineer has traditionally been very hands-on. You walk the site, you eyeball the progress, you check the quality of the work with your own eyes, and you rely on your years of experience to spot problems. This experience is and always will be incredibly valuable. However, the idea of a supervisor whose only skill is walking the site and managing crews is becoming outdated. The modern construction site is a hub of technology, and the supervisor needs to be just as comfortable with a tablet as they are with a tape measure. The preference now is for tech-enabled supervision. This means using project management apps on a tablet to update progress in real time, which instantly notifies the project manager back in the office. It means using drones to get a daily aerial overview of the site, instead of just what you can see from the ground. It means using laser scanners to verify that what's been built matches the digital model down to the millimeter. This integration of technology allows for better documentation, faster communication, and more accurate quality control. The experience is still key, but it needs to be combined with the ability to leverage these powerful new tools. Finally, let's talk about the actual nuts and bolts of construction. Certain traditional methods are being phased out in favor of safer, faster, and higher quality alternatives. A great example is conventional shuttering, or formwork, using timber planks. It's time-consuming to build, can be wasteful, and the quality of the finish can be inconsistent. Today, we have modular, reusable formwork systems made of steel or aluminum that can be assembled and disassembled much more quickly and provide a superior finish. This saves time, reduces waste, and improves safety on site. Another classic example is the manual preparation of concrete mix on site for major structural elements. While it might be fine for a small patio, for a large project, it's impossible to guarantee the consistent quality and strength required. This is being replaced by ready-mix concrete, or RMC, delivered from a batching plant where the mix is computer-controlled for perfect consistency every single time. The theme here is a move towards prefabrication, modularization, and system-based approaches that prioritize quality control, speed, and safety over traditional, labor-intensive methods. Knowing and advocating for these modern practices is a key skill for today's engineer. Okay, so we've covered a lot. You might be feeling a little overwhelmed thinking, how am I supposed to learn all of this? But don't worry, building your skills is just like any other engineering project. You need a good plan. For software like Revit, AutoCAD Civil 3D, and STAAD.Pro, platforms like LinkedIn Learning, Coursera, and Udemy offer fantastic project-based courses. You can expect to spend around 40 to 60 hours to get proficient, and costs can range from a monthly subscription to a few $100s for specialized certification programs. The key is to not just watch the videos, but to actually do the projects. For more advanced topics like project management, pursuing a PMP certification is a bigger commitment, often requiring months of study and documented project experience, with costs running into the thousands. For skills like drone surveying or GIS, look for specialized in-person or online workshops that offer hands-on training with the actual hardware and software. These can be a bit pricier, but offer invaluable practical experience. The most important thing is to start small. Pick one in-demand skill that interests you, dedicate a few hours each week, and build from there. Continuous learning is the new normal, and investing in your skills is the single best investment you can make in your career. So at the end of the day, the world of civil engineering is evolving. The tools are getting smarter, the projects are getting more complex, and the demands on us as engineers are greater than ever. But here's the cool part. That's not something to be scared of. It's an incredible opportunity. All this new technology from BM to drones isn't here to replace us. It's here to augment our abilities, to take the tedious, repetitive work off our plates so we can focus on what we do best: creative problem solving and designing a better, safer, and more sustainable world for everyone. Your career is the most important project you will ever build. It requires a solid foundation of principles, a flexible framework to adapt to new challenges, and a constant process of renovation and upgrades to stay current. Don't be the engineer who's still trying to use a slide rule in the age of supercomputers. Be curious. Be a lifelong learner. Pick one of these skills we talked about today. Dive in and start building. The satisfaction you'll get from mastering a new tool and applying it to create something real is one of the best feelings in the world. And as always, thanks for watching. Now get out there, learn something new, and go build something amazing. The world is waiting for you, and if you're building a giant squirrel-proof bird feeder in your backyard, well, you know who to call. And before you go, don't forget to subscribe to our YouTube channel, and to learn more, visit www.engineersheaven.org. Thanks for watching.